Hello student. In previous class, I discussed the different laws of chemical combination. In the previous class, I completed the law of gaseous volume, that is also called law of combining volume. I have also completed some problem related to the last law, that is law of gaseous volume. These are few problems I have given. This was about the chapter. Today I was Today I will start a new chapter, that is the structure of atom. Today I will explain about a new chapter, that is the structure of atom. Actually, in this chapter we clearly explain about the different theory to explain the structure of atom. What are the subatomic particles present in an atom? So at first, I will discuss about something related to the electron, proton, and neutron. If I will think about an atom, if you will think about an atom, then the atom will break into subatomic particles. When you want to break an atom, then it will give three subatomic particles generally. One is the electron, another is proton, third is your neutron. What is the electron and what are the important points related to the electron? Look at that. An electron is defined as a subatomic particle. Obviously, it is a subatomic particle having a unit negative charge. It having a unit negative charge and a mass equal to 1 by 837 of the mass of hydrogen atom. It is discovered by J.J. Thomson in the cathode ray experiment. In the next, after some time, I will discuss about what is cathode ray experiment, how J.J. Thomson, how J.J. Thomson discovered. Charge of electron is your minus 1.602 into 10 to the minus 19 coulomb. Mass of electron is equal to 9.11 into 10 to the minus 31 kg. Specific charge of electron, remember specific charge of electron means E by M. E by M ratio is said to be specific charge of electron. The specific charge of electron is equal to 1.76 in 10 to the power 80, sorry, 10 to the power 8 coulomb per gram. These are few points related to the electron. What is electron and what is the mass of electron? What is the charge of electron? Who discovered the electron? And what is the specific charge of electron? These are few points related to the electron. Similarly, what is proton? Proton is also a subatomic particle like the electron, but it have the charge is your positive and its magnitude is your 1 unit and a mass equal to that of the hydrogen atom. Here look at that, the electron is very small and it is a 1 by 1837 of the mass of hydrogen atom, but look at that, here the mass of proton is nearly equal to the mass of that is your hydrogen atom. It is discovered by Goldstein. Charge of electron is also equal to the charge of electron. They having same magnitude. Look at that here 1.602 into 10 to the minus 19 coulomb. Here also charge of proton is your 1.602 into 10 to the minus 19 coulomb. But look at that here negative sign is used for electron. Here positive sign is used for charge of proton. Proton is always a positive charge, but electron is a what? Negative charge. Clear? So here I can say that charge of proton. Charge of any subatomic particle is denoted by E. Don't think that E means electron. Actually, electron denoted by E minus. Proton is denoted by H plus. So do not think that E means electron. E means indicate it is a charge. If you think about the electron, then electron is denoted by E minus. So here I can write charge of proton, that is your E is equal to plus 1.602 into 10 to the minus 19 coulomb. Mass of proton is your 1.672 into 10 to the minus 27 kg. Specific charge of proton, that is your E by m value, is equal to 9.8 into 10 to the 14, 10 to the 4 coulomb per gram. Look at that here. Specific charge of electron is your 1.6 into 10 to the 8 coulomb per gram, but specific charge of proton is your 9.58 into 10 to the 4 coulomb per gram. Next, move to the third, that is your subatomic particle. What is a neutron? What is a neutron? Neutron is also a subatomic particle. Remember, electron having charge, that is your negative charge, proton having, that is your positive charge. But here look at that, neutron having, that is your neutral charge. It have no charge. It is a neutral subatomic particle, and its mass nearly equal to the mass of hydrogen atom. It having also mass nearly equal to hydrogen. Look at that. If you think about the mass of neutron, the mass of neutron is your how much? 1.675 into 10 to the minus 27 kg. Mass of proton is your how much? 1.672 into 10 to the minus 27 kg. Mass of neutron and mass of proton are nearly equal to each other, and they are also similar, also nearly equal to the mass of the hydrogen. Next, if you think about neutron, then neutron is discovered by James Chadwick. James Chadwick discovered the neutron. Your charge of neutron is your zero. Mass of neutron already I told you. Or specific charge of neutron, that is your E by m is equal to zero. Why? A value specific charge of neutron means E by m. E means charge, m for mass. Here the charge is your zero. No doubt it has some mass, but what happens? The result is your also zero. Here E value is your zero, but it has some mass, that is your 1.675 into 10 to the minus 27 kg. 0 by something means zero. So here I can say that specific charge of neutron E by m is equal to zero. This is some points regarding about the electron proton. Next, I will move to the discover of electron. It is discovered by J.J. Thomson. How how did how did the scientist discover this? Let me explain. Look at that. He have carried out an experiment. In his experiment, at first he have taken a discharge glass tube. This is your said to be discharge glass tube. This is your said to be discharge glass tube. Look at that. This is your said to be discharge glass tube. And one end of the discharge tube is fixed with the cathode, and another end is fixed with the anode. This is your anode, and this is your said to be cathode. These are two electrodes are fitted in the discharge glass tube, and the cathode is joined to the negative part of the battery. This is a symbol of battery, high voltage battery. This is your minus, this is your plus. The cathode is joined with the negative electrode of the negative part of the battery, and while the anode is attached with the positive part of the battery. Here a vacuum pump is fitted with the discharge glass tube, because it remove the air and maintain a pressure of 0.03 mm. Look at that. The high voltage means the voltage more than nearly equal to, that is your 30,000 volt. 30,000 volt. Again, I want to speak the arrangement. At first, we have taken a discharge glass tube. Then two electrodes are fitted. One is the cathode, another is the anode. The cathode is attached to the negative terminal of the battery, and the anode is attached with the positive terminal of the battery. And a vacuum pump is fitted to maintain the pressure 0.03 mm. When J.J. Thomson passed high voltage electric discharge, that is nearly equal to 30,000 volt, then what at a low pressure. Again, I want to speak. When an electric discharge, that is your nearly 30,000 volt, is passed through the gas at a very low pressure, the gas is present in the discharge tube. Here, gas is present, and the gas is present at low pressure. The pressure is your 0.03 mm. Again, I want to repeat. When an electric discharge nearly 30,000 volt is passed through the gas, which is present in the discharge glass tube at a very low pressure, that is your 0.03 mm, in a discharge tube. This is your discharge tube, that is your discharge glass tube. Then what happened? A stream of bluish light. A stream of bluish light are seen proceeding normally from the cathode to anode. When 30,000 volts of electric discharge is passed through this discharge tube, in which a cathode is present and an anode is present, and a gas is present, and the gas is present at with 0.03 mm pressure, then what will happen? Then what happened? A stream of bluish light comes from cathode to anode. This electrode to this electrode. These are the rays. These are the cathode rays. Comes from they started moves from cathode to anode. These are the rays proceeding normally from the cathode to anode. These ray consist. If you want to check the charge of this ray, then it shows the negative charge. How did James Chadwick prove that these charge carry negative charge? I will discuss later. What happened? A stream of bluish light are seen proceeding normally from the cathode to anode. From the cathode to anode, and these ray carry negative charge. They are negative charge particle, so they are called negative ray, or that is your cathode ray. Let me explain the properties of the ray. The ray which are produced and moved from the cathode to anode. Now let me explain the properties of the cathode ray. At first, I want to say that you can take the gas like hydrogen, helium, nitrogen, or air, and you also change different type of electrode here. That is your iron, platinum, copper. The cathode and anode may be changed. Maybe it is made by different material, and the gas present in the discharge tube maybe any type of gas, that is your maybe hydrogen, maybe helium, maybe nitrogen or air. But remember, the properties of cathode ray do not depend. That means the property of cathode ray do not change with the change of the material of the electrode and the nature of the gas present in the discharge tube. We can say that the property of cathode ray do not depend on the material of the electrode or the nature of the gas present in the discharge tube. If you take any type, that means you take any type of gas or electrode, however, the property of the cathode ray will not change. This is the first property of cathode ray. Next, I want to move the second property. Cathode ray are material particles. The scientist, that is your J.J. Thomson, said that he concluded that the cathode ray are material particles. That means these are the particles, small particles like, and when they hit, when they strike to a light mica pedals. This is your mica pedal. Look at that. This is your mic pedal. It is a one type of wheel. When the cathode ray strike, when the cathode ray comes from the cathode, strike to the mica pedal wheel, then what happened? The mica pedal wheel will start rotate. This rotate like this. This is your rotation. That means some force will that means some force must applied on the wheel. As a result, the mica pedal will rotate. Otherwise, it is impossible. Without any force on the mica pedal wheel, the pedal will not rotate. From this rotation of the mica pedal wheel, it is seen that the ray must have some particle natures. So, since the light mica pedal started rotate, as a result, we can see that cathode ray having material particles. So here you can see that cathode ray are material particles as they rotate a light mica pedal placed in their path. If you will place a mica pedal on the path of the cathode ray, which comes from the cathode to anode, then what will happen? The pedal will start to rotate. So the observation is your what? The mica pedal will rotate when the cathode ray strike it. So here we can think about the conclusion, that is your cathode ray consists of particle having mass and momentum. It having some mass and also it having some momentum. Next point is your cathode ray carry negative charge. Here the third point is your cathode ray carry negative charge because the cathode ray moves towards the positive plate. Look at that. The charge of cathode ray is your what? Negative. Because it is attached to the negative terminal of the battery. Since the cathode attached with the negative terminal, that means it must be your negative charge, and it also proved from the flow of the cathode ray from cathode to anode. Look, that means I want to say that since the cathode ray start moves from cathode to anode, that flow from cathode to anode. Anode is the positive. We know that always the opposite charge to attract to each other. Since cathode connected to the negative terminal of the battery, so the electrode must be your negative electrode. Anode connected to the positive terminal of the battery, so it is your positive electrode. The ray start moves from negative electrode to which electrode? Positive electrode. That must be negative, otherwise it cannot start moves towards the anode. Since anode is positive, so the ray must be negative. Otherwise, the ray will not comes towards the anode. So here I can say that cathode ray carry a negative charge because they are moved towards the positive plate. Okay. Next, another property is cathode ray travel in a straight line from cathode to anode. Already we know that cathode ray travels from cathode to anode. But here another point is that cathode ray travel in a straight line. Cathode ray travels in a straight line. If you put an object, this is your opaque object. Opaque object means here no light will pass in this object. Then I will keep a opaque object in the path, in the straight line path of the cathode ray. Then what will happen? A shadow will form. This is the shadow. This is the opaque object. A shadow here formed. That means here I can say that cathode ray travel in a straight line. Since it moves in the straight line and does not pass through the opaque object, as a result, a object will form. If it will travel, if it, it will not travel in a straight line, it can move, it can change its direction. Then here no shadow of the object then here no shadow of the object will form. So since here I can say that since and shadow is formed when the scientist J.J. Thomson kept an opaque object in the path of the cathode ray, then a shadow is formed. From this concept, it is seen that cathode ray travel in a straight line from cathode to anode, as shown by the shadow formed by an object placed in their path. Next point is cathode ray travel in a straight line unless they are deflected by electric or magnetic field. Actually, what happened? Cathode ray moves in a straight line from cathode to anode. When you put an opaque object, then a shadow is formed, which confirms that cathode ray move in a straight line. Now it is confirmed that cathode ray move in a straight line. But remember, when you apply an electric field or magnetic field to to these rays, the stream of bluish light which comes from cathode to anode, then what happened? They change their direction. Look at that in this diagram. Look at that. Actually, the cathode ray should travel in a straight line, but when I applied an electric field between two plates, here the cathode, here the anode, when I applied an electric field, what happened? The direction of the cathode ray changed towards, comes towards the bottom, towards the positive. That means here I can say that cathode ray are deflected by electric field. Similarly, when you will put in magnetic field, then it also deflected. So here I can say that they are also deflected by an magnetic field. So here a point uh, have written, that is your cathode ray travel in a straight line unless they are deflected by electric or magnetic field. When you will put, when you will keep an electric or magnetic field, then the cathode ray change its direction. The cathode ray deviated the straight from the straight line path. Next point is your cathode ray causes, that is your ionization of gas. That means when cathode ray strike to the gas molecules, then the gas molecule start to converted into atom. Then again, when the cathode ray strike to the atom, then what happened? The atom may loses electron or gain electron. That means it may convert it into positive ion or may convert it into may convert it into the negative ions. It may loses electron or gain electrons. Look at that here. Generally, it loses electron when the cathode ray undergoes flow from cathode to anode. Then in between the gas present in between the cathode ray and anode ray start ionization. Again, I want to repeat, when cathode rays travel from cathode to anode, then the gas present in between these two electrodes start ionize. So here I can say that cathode ray causes ionization of gases. Next, move to the another point. Cathode ray produce fluorescence and phosphorescence when they strike suitable material. What is fluorescence? I want to say that what is fluorescence? Fluorescence actually is the phenomena in which a substance absorbs light at one wavelength and almost immediately emit light at a longer wavelength. They emitted light usually stop within a nanosecond after the excitation source is removed. That means I want to say that you know very well some object, some substance absorb the light and keep the light few nanosecond, and after cut off of the source, after cut off the light, the object still shows lighting for a few nanosecond. You know very well about different types of lights. When power is uh, cut off a few nanosecond, the light all source glow. Similarly, if you think about the phosphorescence, phosphorescence is also a phenomenon in which a suitable substance absorb energy and then continue to emit light even after the exciting source has been removed. That means both are both emitted light. Fluorescent substance emit light, phosphorescent substance emit light. Both emit light after cutoff of the exciting source. But remember, fluorescent substance shows for a nanosecond, but phosphorescent substance shows more times as compared to the fluorescent substance. Uh, so here I can say that when cathode ray strike to a suitable metal, then what happened? The substance started glow. That means we can say that cathode ray produce fluorescence and phosphorescence when they strike suitable material. When cathode ray strike to a suitable material, then it starts to glow. After the cutoff of the source, in case of fluorescence, it shows the emission of light for a few nanosecond. But in case of phosphorescent substance, it shows more time. It emit light more time as compared to the fluorescent substance. So again, I want to say that cathode ray produce fluorescence and phosphorescence when they strike suitable material. Look at that here. A diagram is given. Look at that here. When ray start passes from cathode to anode, then what happened? And when ray off, that means there is no flow of ray from cathode to anode. Look at that. In case of fluorescence, what happened? Actually, the cathode ray start flow from cathode to anode. When I will keep a fluorescent, this is the fluorescent substance. When cathode ray falls on the fluorescent substance, then look at that, it start glow. The screen glows. But when rays off, that means the ray do not fall on the fluorescent substance. Then look at that, the glow stops instantly. Few nanoseconds. It shows the glow emission of light for a few nanoseconds. But so here I can say that the material glow only when cathode ray are striking it. The glow stop instantly when the ray are stopped. Similarly, if you think about the fluorescence, look at that. Here the ray comes from cathode to anode. This is the this is the phosphorescence substance. When cathode ray strike to the that is fluorescent substance, then it starts to glow. But if the light off, if the ray will off, then what is just stop. Then it glow will continue few time. But after some times, glow gradually fades and then stop. The only difference is it is suddenly stop. Here it takes some times to stop. It shows the emission. It shows the glow for a nanosecond, but it shows the glow more times as compared to the fluorescent substance. This is the only difference. Look at that in this diagram. Uh, Clearly, I have explained. Next, here I can say that cathode ray produce heating effect when they strike a metal foil. Here I have taken a metal foil. Look at that. This is the metal foil. This is the metal foil. Look at that. When cathode ray strikes on the metal foil, then what happened? The temperature of the metal goes on increases. So here I can say that foil get heated and its temperature rises. This is the metal foil. That means it create heating. It increase the temperature when cathode ray strike. So here I can say that when cathode ray strike a metal foil, the foil become hot. This show that cathode ray produce heating effect. This is the metal foil becomes hot. Next point is cathode ray produce X-ray. You know that what is X-ray? Cathode ray produce X-ray when strike the surface of hard metal such as tungsten, molybdenum, etc. Look at that. In this diagram, I have taken a hard metal. Maybe I have taken here tungsten. This is maybe tungsten. You can take any hard metal, that is your tungsten, molybdenum, etc. Here I have taken a hard metal, that is your tungsten. When I passed the cathode ray, when the cathode ray fall on the hard metal, then what happened? It will loses electron and also emit X-ray. So here I can say that when cathode ray, that is your electrons, strike the surface of a hard metal target such as tungsten or molybdenum, highly penetrating electromagnetic radiation called X-ray are produced. The X-ray, you know very well, it is used for the scanning purpose in the medical field. Travel in straight line. Generally, the ray are travel in straight line, not deflected by electric or magnetic field. Highly penetrating, can produce fluorescence and photographic effect. Travel with the speed of light. So here I can say that cathode ray produce X-ray when they strike the surface of the hard metal such as tungsten and molybdenum. Look at this diagram. In this diagram, I have presented the formation of X-ray. Next point is cathode ray have penetrating effect. Cathode ray can pass from from one side to another side through a thin metal foil. Look at that. Here I can say the cathode ray have penetrating effect and thus can pass through thin foil of metal. However, these are stopped if the foil is quite thick. Look at that. Here cathode ray. This is the cathode. This is the anode. Here cathode ray flow from cathode to anode. This is the direction of flow of cathode ray from cathode to anode. Look at that. If I will keep a thin metal foil and I will pass the cathode ray, and the cathode ray travels from cathode to anode. Look at that. Here, some ray are passed through the thin metal foil. Cathode ray pass through a thin metal foil and produce fluorescence on the screen. If you will place a thick metal foil, then what happens? The cathode ray cannot pass the thick metal foil. So here I can say that cathode ray are stopped by thick metal foil and no fluorescence is seen on the screen. That means here you can say that cathode ray can penetrate the thin metal foil, but it cannot penetrate the thick metal foil. Next, cathode ray affect the photographic plate. You know that about the photographic plate. Let me show the photographic plate. Here a photographic plate is placed. When the cathode ray strike to the photographic plate, then what happens? Look at that. That portion which is strike the portion in which the cathode ray felt, that portion look like black. Look at that. Cathode ray strike the photographic plate. The plate get exposed. When the cathode ray fall on the photographic plate, then the plate start expose. After what few times, look at that. The exposed plate develop a dark image. This is the dark image at the place where the cathode ray it is just struck it. This is the development of the dark image. Uh, so here I can say that. So here I can say that cathode ray affect the photographic plate. These are the few properties of cathode ray. Again, I want to revise what are the properties of cathode ray. In the look at that, listen a important point in this in this diagram. Few parts are wrong, so uh, do not think about the wrong diagram. Just I have given the diagram for your better understanding, but when I will supply the note, I do not give uh, I will not give these parts. I will omit such diagram, because such diagrams are actually not 100% correct. I just have kept in the word document for your better understanding, and it is easy to understand. It is easy to understand. As a result, I have kept the diagram in the word file. So when I will provide the note, I will delete this diagram, only I will give the sentence. So again, I want to repeat, what are the property of cathode ray? The property of cathode ray do not depend on the material of the electrode or the nature of the gas present in the discharge tube. Second is cathode ray are material particle as they rotate a light mica pedal placed in their path. Third is cathode ray carry negative charge because they are moved towards the positive plate. Next, fourth is cathode ray travel in a straight line from the cathode to anode, as shown by the shadow formed by an object placed in their path. Next, cathode ray travel in a straight line unless they are deflected by electric or magnetic field. Next, cathode ray causes ionization of gases. Next is your cathode ray produce fluorescence and phosphorescence when they strike suitable material. Next is cathode ray produce heating effect when they strike a metal foil. Next is cathode ray produce X-ray when they strike the surface of the hard metal such as tungsten, molybdenum, etc. Next is cathode ray have a penetrating effect and thus can pass through thin foil or metal. However, these are stopped if the foil is quite thick. Next, cathode ray affect the photographic plate. These are few properties of cathode ray. Next, I want to move to the determination of mass of an electron. We know that value of E by M. E by M means that is, or we can say that what is specific charge. Both the three subatomic particles, electron, proton, and neutron, having the specific charge value. Look at that. We know that the specific charge of electron, that is your 1.76 into 10 to the 8 coulomb per gram. Now our target to find out the, look at that, our target to find out the mass of electron. Mass of electron, look at that. We know that the charge of electron is your how much? 1.602 into 10 to the minus 19 coulomb. And the specific charge of electron, that is your E by M value, is your 1.7588 into 10 to the 8 coulomb per gram. Look at this mass of electron. Mass of electron, here I can by using these two data I can find the mass of electron. Look at that, mass of electron means here I can write charge of electron. Charge of electron, that is your E, divided by what? Specific charge of electron. Specific charge of electron. So here I can write, that is your charge of electron is your how much? 1.602 into 10 to the power minus 19 coulomb. Divided by specific charge of electron means, that is your 1.7588 into 10 to the power 8 coulomb per gram. Look at that. Here charge of electron is your E. Specific charge of electron means E by M. Now if you want to solve, then here I can say that E by E into M. Now cancel E, then you will find M value. M means here we can say that mass of electron. So look at that calculation here. I have given, that is your 1.602 into 10 to the minus 19 coulomb, and I have also written the value of E by M, that is your 1.7588 into 10 to the power 8 coulomb per gram. When you want to simplify, then you will get 0.9109 into 10 to the power minus 27 gram. When you convert, change the change the point, that is your decimal. Change the point, then you will get 9.109 into 10 to the power minus 18 gram. When you want to convert the gram into kg, then you will write 9.109 into 10 to the power minus 31 kg. This is already uh, present in from the initial of this chapter. Now, relative mass of electron. Relative mass of electron means, remember an important point. Relative mass of electron means the mass of electron is now compared with the mass of hydrogen. Here I can say that 1 gram atom of hydrogen, 1 gram atom of hydrogen, that is your gram atomic mass of hydrogen, means what? We know already, 1.008 gram. This is the weight of 6.022 into 10 to the 23 hydrogen atom. So here we can have, already I discussed in the mole concept, uh, how they are related, how the mass and mass are related, mole and mole relation. Then I already covered the mass volume relation. There are different relation I already covered in the first chapter. So here I can say that weight of 6.022 in 10 to the 23 of hydrogen atom is your how much? 1.008 gram. If you want to find out the weight of one hydrogen atom, so here I can say that weight of one atom of hydrogen means 1.008 divided by 6.022 in 10 to the 23. If you want to solve, then look at that. Weight of one atom of hydrogen is your how much? 1.673 into 10 to the power minus 24 gram. Our target to find out the relative mass of electron. For the relative mass of electron means, you can say that mass of hydrogen atom divided by mass of electron. If you want to find out the relative mass of proton in the upcoming time, in this in the upcoming I will discuss about the relative mass of proton. Here I can say that relative mass of proton, you can write like this: mass of hydrogen atom divided by mass of, that is your proton. Similarly, you think about also the neutron. Look at that. Now let me explain about the relative mass of the electron. For the relative mass of electron, you can say that mass of hydrogen divided by mass of electron. Mass of hydrogen means how much? 1.673 into 10 to the minus 24 gram. So here I have written 1.673 into 10 to the minus 24 gram. Mass of electron, that is your how much? 9.109 into 10 to the minus 28 gram. If you want to solve, then you will get 0.1836 0.183 I can read like this: 0.18366 into 10 to the 4, which is equal to 1837. So here I can say that mass of electron is equal to mass of hydrogen divided by 1837. This is already I have presented in the first page. Look at that. What is electron? Electron is defined as a subatomic particle having unit negative charge and mass equal to how much? 1 by 1837 of the mass of hydrogen atom. Already I told you. So now here I proved how they are related. Look at that. If you think about the relative mass of electron, here I have written mass of electron is equal to how much? Mass of hydrogen atom divided by 118 divided by 1837. Again I want to say mass of electron is equal to mass of hydrogen atom divided by 1837. So here I can say that an electron has a mass An electron has a mass that is 9.1 into 10 to the minus 31 kg, equal to 1 by 1837 of that of a hydrogen atom. Next, move to the discover of proton. It is just similar with the discover of that is your electron. Here we can say that anode ray experiment. This was cathode ray experiment. Now this is your anode ray experiment. Cathode ray experiment is proposed by, discovered by J.J. Thomson, but anode ray experiment is discovered by Goldstein. This is the scientist, that is your Goldstein, discovered the anode ray experiment. The only difference is the cathode, that is your electrode, that is your cathode. In the cathode ray experiment, what happened? Look at that. Here a cathode electrode is used, but here there is no hole. It is a solid electrode. Here you will not find a hole. This is a solid. Here no hole is present. But if you think about the Goldstein experiment, that is your anode ray experiment, here also a cathode is present. Here also a cathode is present. But in the cathode there are some holes are present. Here some holes are present, so it is said to be perforated cathode. Perforated cathode means the cathode plate in which some holes are present. That is said to be perforated cathode. And the same arrangement like the cathode ray experiment, here also the arrangement is performed. Look at that. Here also cathode is present, here also anode is present. Here the cathode is in this cathode some holes are present, that is said to be perforated cathode. Here also high voltage is passed. Here this is your discharge tube. This is your discharge tube, glass discharge tube. Here also vacuum pump is fitted like the cathode ray experiment. Here this is your anode. When high voltage when high voltage discharge is passed through the glass tube, then what happened? We already know that a stream of bluish light is a stream of bluish light is flowing from cathode to anode. This is already I discussed in the cathode ray experiment. But what is the extra thing here? Goldstein wants to explain. Look at that. When a solid cathode will kept in the discharge tube, and it act as a cathode electrode, then only the bluish streamlight will pass from cathode to anode. But Goldstein replaced the solid cathode, and he placed a perforated cathode. That means hole. There are holes. Some holes are present in the cathode plate. Then what happens? Actually, the cathode ray starts move from cathode to anode, but in the opposite side, also few ray are also formed. These rays are called anode ray. Look at that. These are said to be cathode ray. These are said to be cathode ray. Already I discussed in the cathode ray experiment, which moves from cathode to anode. These are said to be cathode ray. It having carry the negative charge. But if you think about this side, here also the ray comes. Here also the ray start in the opposite direction of the cathode ray. Here this ray start moves in the opposite direction of the cathode ray. The cathode ray moves in this direction, this in that direction like this, from cathode to anode. But here these ray flow in the back side of the perforated cathode, which is opposite to the direction of the cathode ray. Again, I want to repeat. When electric discharge was passed through a gas, your gas is present. When electric discharge was passed through a gas at low pressure, streams of luminosity were seen at the back of the perforated cathode. at the back of the perforated. This means these are the ray which are formed in the back of the perforated cathode. The rays were found to travel in the direction of opposite to what? Those of the cathode ray and to pass through the hole in the cathode. This ray comes from the holes. These ray consist of positive charge. If you want to find the charge of this ray, then you will see the positive charged particle. These are positive charged ray. So here we can say that these ray are said to be positive ray. That is your anode ray, or you can say that canal rays. These are the this experiment is done by Goldstein. Just modified the cathode electron in the discover of the electron in the cathode ray experiment. J.J. Thomson take the solid cathode, but here Goldstein again uh, performed the same test, but here he have taken the perforated cathode. That means there are some holes present in the cathode. Then what are the observation? Uh, Goldstein found. Look at that. That means we want to say that the property of anode ray. Like the listen an important point. The cathode ray do not depend upon the nature of the gas present in the discharge, and also do not depend upon the material of the electrode. But here is here the property of anode shows slightly different. The property of anode ray depend on the nature of gas present in the discharge tube, but are independent upon the material of the electrode. You can change any material of the electrode, but the property of the anode ray will not change, like the cathode ray. But if you want to change the gas present in the discharge tube, then the property of the anode ray will change, because actually anode ray comes from the gas. So if you will change the gas, then obviously different types of anode ray will come. So remember, again I want to say that cathode ray do not depend upon the nature of gas and nature of the material. But remember, anode ray depend on the nature of the gas present in the discharge tube, but are independent upon the nature of the electrode. Like the cathode ray, anode ray also shows the particle nature. That means they are material particle, because like the cathode ray, they also rotate the light mica pedal placed in their path. Next, anode ray carry positive charge, because the ray move towards the negative plate, because the ray start in the flow in the back side of the perforated cathode, and it is also opposite to the cathode ray. So that means the it is again I want to say that since the anode ray moves in the opposite direction of the cathode ray, so the anode ray shows the opposite charge to the cathode ray. Cathode ray shows the negative charge, so anode ray must shows the positive charge. So here I can say that anode ray carry positive charge because they are moved towards the negative plate. Similarly, you can think about the anode ray travel in a straight line from the region of anode towards cathode. But listen, here I have written from the region of anode. Here I cannot write from the anode to cathode. From the region of anode means from the surrounding of the anode. You cannot say that the anode ray comes from the anode electrode, because the anode ray formed from the gas. But if you think about the cathode ray, you can say that the cathode ray travels from cathode electrode to anode electrode. So here I can say that the anode ray carry a positive charge because they are moved towards the negative plate. Next, anode ray travel in a straight line from the region of anode to anode towards the cathode. Next is anode ray travel in a straight line unless they are deflected by electric or magnetic field like the cathode ray. Anode ray causes ionization of gases like the cathode ray. Anode ray produce fluorescence and phosphorescence when they strike suitable material. This is also like the cathode ray. Next, anode ray produce heating effect when they strike a metal foil. This is also like the cathode ray. Next, anode ray have a penetrating effect and thus can pass through thin foil of metal. However, they are stopped if the foil is quite thick. This is also like the cathode ray. This is also like the property of cathode ray. Anode ray affect the photographic plate like the cathode ray. These are few properties of anode, and the many properties are similar with the cathode ray, and some properties are just opposite to the cathode ray. Next, I want to find out the mass of proton. Already we know that charge of proton is your 1.602 into 10 to the minus 19 coulomb. Value of E by M, that is the specific charge of proton is your 9.579 into 10 to the 14 coulomb per gram. The mass of proton means E by M, that is your charge of proton divided by specific charge of proton. Here E is your 1.602 into 10 to the minus 19 coulomb. E by M means here 9.579 into 10 to the 4 coulomb per gram. So here I can say that mass of proton is equal to how much? 1.672 into 10 to the minus 24 gram. This value will find after solving this that is your division. So here I can say that mass of proton is your how much? 1.62. Sorry, mass of proton is equal to 1.672 into 10 to the minus 24 gram. If I want to convert from gram to kg, then here I can write 1.672 into 10 to the minus 27 kg. This is a mass of proton. In the next period I will explain about what is the Thomson model of the atom, that is your also called raisin pudding model, that is your plum pudding watermelon model. I will explain in the next period. For this class this is very sufficient. Finally I want to say an important point. If you want to know, if you want note of the class, then you will go to the description, then you will find a link. If you want to click the link, then you will get the note of the today class. Thank you all for watching on this video. Have a nice day.